Hi doctor, my name is Raja. I am from group 1. We choose topic 1 which is about energy transfer for our group project. So first of all, let me to do introduction for our topic which is energy transfer. The first law of thermodynamics deals with the total amount of energy in the universe. Energy exists in many different forms. According to the first law of thermodynamics, energy may transfer from place to place or transforms into different forms, but it cannot be created or destroyed. The transfer and transformation of energy takes place around all the time. Therefore, it is important to have a good understanding of sources of energy, the conversion of energy from one form to another, and the ramification of this conversion. Energy exists in numerous or numerous forms such as thermal, mechanical, electrical, chemical, and nuclear. Energy can be transferred to or from closed system or a fixed mass into two distinct forms, which is heat and work. So now I want to explain about the objective of our group project. First, we want to introduce the concept of energy and define the various forms. Second, we want to define the concept of heat and terminologically associate with energy transfer by heat. Third, we want to discuss the three mechanisms of heat transfer, which is conduction, convection, and radiation. We want to define the concept of work, including electrical work and several forms of mechanical works. Define energy and conversion of efficiency. So this one can be known as conversion efficiency. Lastly, we want to discuss the implication of energy conversion on the environment. Other than this, end of this group project, we want to submit some problems and solutions for the energy transfer. So now I want to explain about some form of energies. There are various types of energies. Energy can exist in numerous forms such as thermal, mechanical, kinetic, potential, electric, magnetic, chemical, and nuclear, and etc. etc. Thermodynamics deals only with the change of total energy, which is delta E. Internal energy, we can say internal energy is the U, the sum of the microscopic forms of energies. Kinetic energy is, we can say, Ke, the energy that is a system possesses as a result of its motion relations to reference times and frames. Potential energy, we can call Pe, the energy that a system possesses a result of its elevation in a gravitational field. So now I want to explain some physical insight to internal energy. So this one can be identified into 5 energies, which is sensible energy, latent energy, chemical energy, and nuclear energy. So what is sensible energy? Sensible energy is the portion of internal energy of a system associated with the kinetic energy of the molecules. Then what about latent energy? The initial energy associated with the pace of a system. So now I want to go into energy in a system. So what is energy in a system? The total energy of a system can be contained or stored in a system and thus can be viewed as the static form of energy. The form of energy not stored in a system can be viewed as the dynamic forms of energy or energy interactions. The dynamic forms of energy are recognized at the system boundary as they cross the boundary and they represent the energy gained or lost by a system during the process. By this process, energy are transferred by crossing the boundary. The only two forms of energy interactions associated with the closed system are heat transfer and work. The difference between these both energy transfer is energy interaction in heat transfer if it is driving forces in temperature differences, otherwise it is work. So now I finished chapter 2, which is about various types of energies. I want to continue with my friend to other chapters. Thank you.
Hello, my name is FAKHRUL ARIFFIN. Now I will talk about energy transfer. The first is energy transfer by heat. Heat is the form of energy that is transferred between two systems or a system and its surrounding by virtue of a temperature difference. In closed system, energy can cross the boundary of the closed system in the form of heat and work. Temperature difference is the driving forces for heat transfer. The larger the temperature difference, the higher is the rate of heat transfer. Heat transfer per unit mass as the unit of kilojoule per kilogram. Amount of heat transfer when heat transfer rate is constant has the unit of kilojoule. Amount of heat transfer when heat transfer rate change with time has also the unit of kilojoule. For the next one is surrounding air. So from the 2 kilojoule thermal energy is converted to 2 kilojoule of heat, and to the surrounding 2 kilojoule of thermal energy back. Recognized as heat transfer only as it cross the system boundary. During an adiabatic process, a system exchange no heat with its surrounding. It is because there is an insulation in the system. 3.2 Heat transfer mechanism. Conduction is the transfer of energy from the more energetic particle of a substance to an adjacent less energetic one as a result of interaction between particles. Convection, the transfer of energy between a solid surface and the adjacent fluid that is in motion, and it involves the combined effect of conduction and fluid motion. Radiation, the transfer of energy due to the emission of electromagnetic wave or with a photon. 3.3 Energy transfer by work. Work is the energy transfer associated with a force acting through a distance. A rising piston, a rotating shaft, and an electric wire crossing the system boundary are all associated with the work interaction. Formal sign convention, heat transfer to a system and work done by a system are positive, while heat transfer for a system and work done on the system are negative. Alternative to sign convention is to use the subscript in and out to indicate direction. This is primary approach in this step. Thank you.
My name is Muhammad HADRAMI bin ZAINORIDIN. I will present about forms of work. For mechanical forms of work, there are two requirements for a work interaction between a system and its surrounding to exist. First, there must be a force acting on the boundary, and second, the boundary must move. The formula for work is force times to distance. For shaft work, a force F acting through a moment arm R generates a torque T, and formula for shaft work is T equal to F times 4R. and this force acts through a distance s, which is s equal to 2 pi r times 2n. The power transmitted through the shaft is the shaft work done per unit time. For spring work, when the length of the spring changed by a differential amount dx under the influence of a force F, the work done is delta W spring equal to F times 2 dx. For linear elastic springs, the displacement x is proportional to the force applied, F equal to k times 2x, and the displacement of a linear spring doubles when the force is doubled. This diagram shows the elongation of a spring under the influence of a force. For work done to raise or to accelerate a body, first, the work transfer needed to raise a body is equal to the change in the potential energy of the body. And second, the work transfer needed to accelerate a body is equal to the change in the kinetic energy of the body. We go next to the non-mechanical forms of work. For electrical work, the generalized force is the voltage, and the generalized displacement is the electrical charge. For magnetic work, the generalized force is the magnetic field strength, and the generalized displacement is the total magnetic dipole moment. For electrical polarization work, the generalized force is the electrical field strength, and the generalized displacement is the polarization of the medium. The energy transfer to a body while being raised is equal in the change in its potential energy.
Hello, my name is Tinagaran. Today I am going to talking about the energy balance. The net change, increase or decrease in the total energy of the system during a process is equal to the difference between the total energy entering and the total energy leaving the system during the process. The formula is total energy entering the system minus total energy leaving the system equals to change in the total energy of the system. 5.1 Mechanism of energy transfer, E in and E out. Heat transfer, work transfer, mass flow. A closed mass involves only heat transfer and work. The energy content of a controlled volume can be changed by mass flow as well as heat and work interactions. 6.0 Energy conservation efficiencies. Efficiency is one of the most frequently used terms in thermodynamics, and it indicates how well an energy conversion or transfer process is accomplished. Formula: performance equals to desired output over required input. Efficiencies of a water heater: the ratio of the energy delivered to the house by hot water to the energy supplied to the water heater. Efficiencies of combustions: N combustion equals to Q over HV. Amount of heat released during combustion over heating value of the fuel burnt. Heating value of the fuel: the amount of heat released when a unit amount of fuel at room temperature is completely burnt and the combustion produced are cooled to the room temperature. Low heating value LHV, when the water leaving as a vapor. High heating value HHV, when the water in the combustion gases is completely condensed and thus the heat of vaporization is also recovered.
Assalamualaikum. My name is Muhammad ASHRAAF bin Abdul RAZAK, metric number CD190174. Now I want to talk about energy and environment. The conversion of energy from one form to another often affects the environment and the air we breathe in many ways. The study of energy is not complete without considering its impact on the environment. Pollutants emit during the combustion of fossil fuels are responsible for smoke, acid rain, and global warming. The environmental pollution has reached such high levels that it became a serious threat to vegetation, wildlife, and human health. This caused a lot of problems in the environment. First, we look at ozone and smoke. Smoke is made up mostly of ground level ozone, but it also contains numerous other chemicals, including carbon monoxide, particulate matter such as soot and dust, volatile organic compounds such as benzene, butane, and other hydrocarbons. Hydrocarbons and nitrogen oxides react in the presence of sunlight or hot, calm days to form ground level ozone. Ozone irritates eyes and damages the air sacs in the lungs where oxygen and carbon dioxide are exchanged, causing eventual hardening of this soft and spongy tissue. It also causes shortness of breath, wheezing, fatigue, headaches, and nausea, and aggravates respiratory problems such as asthma. The other serious pollutant in smoke is carbon monoxide, which is a colorless, odorless, poisonous gas. It is mostly emitted by motor vehicles from the exhaust of the car or vehicles. It deprives the body's organs from getting enough oxygen by binding with the red blood cell that would otherwise carry oxygen. It is fatal at high levels. Suspended particulate matters such as dust and soot are emitted by vehicles and industrial facilities. Such as particles irritate the eyes and the lungs. Now we look at acid rain. The sulfur in the fuel reacts with the oxygen to form sulfur dioxide, which is an air pollutant. The main source of sulfur dioxide is the electric power plants that burn high sulfur coal. Motor vehicles also contribute to sulfur dioxide emissions since gasoline and diesel fuel also contain small amounts of sulfur. The sulfur oxides and nitric oxides react with water vapor and other chemicals high in the atmosphere in the presence of sunlight to form sulfuric and nitric acids. The acids formed usually dissolve in the suspended water droplets in clouds or fog. These acid-laden droplets, which can be as acidic as lemon juice, are washed from the air onto the soil by rain or snow. This is known as acid rain. Sulfuric acid and nitric acid are formed when sulfur oxides and nitric oxide react with the water vapor and other chemicals high in the atmosphere in the presence of sunlight. So, in the daytime, there are many chemicals react to form pollutants because most of the vehicles and factory release a lot of chemicals that bounded with the sunlight and the outer air to form dangerous pollutants. Now we are in the conclusion. This chapter discusses mechanism involved in energy transfer. The energy of molecules is normally considered to be present in three forms: translational, rotational, and vibrational. In a system at equilibrium, at any temperature, the amounts of energy held in these three forms must be related to each other, as each is determined by the temperature. The interconversion of rotational and translational energy is much more facile than the vibrational translational transfer considered. The rate of redistribution is obtained by applying a rapidly varying energy perturbation and observing the rate of adjustment of the system. If the adjustment is low, the temperature obtained by the observation of the translational kinetic will differ from the value which would be estimated from the distribution of rotational or vibrational energy. To distinguish between these estimates of temperature, the terms translational, rotational, and vibrational temperature are frequently applied to them. The equilibrium distribution of translational energies is set up extremely rapidly and so that permissible, as will be done here, to refer to the translational temperature simply as the temperature. The first law of thermodynamics states that energy can either be created or destroyed, only altered in a form. In analyzing an open system using the first law of thermodynamics, the energy into the system is equal to the energy leaving the system. The amount of energy transferred across a heat exchanger is dependent upon the temperature of the fluid entering the heat exchanger from both sides and the flow rates of those fluids. If the fluid passes through various processes and then eventually returns to the same state it began with, the system is said to have undergone a cyclic process. The first law is used to analyze a cyclic process. The energy entering any component is equal to the energy leaving that component at steady state. Thank you.